Once again, a very good morning, students. In the previous video, we have come across how to write last year's price index number and past year's price index number. Now we have to concentrate on the next index number, which is Marshall-Edgeworth price index number. So weights assigned are the average of base year and current year quantities here, as we know already. First one is last year's. There it was considered base year quantities as the weights. And then next it was past year's price index number. There the weights applied was current year quantities. Here next Marshall-Edgeworth price index number, we are having the weights as the average of base year and current year quantities. So how to write the formula? P01 as usual notation, this ME will represent Marshall-Edgeworth is equals to the sum of P1 and sum of P0 is as usual format how we have seen in the previous two index numbers, last year's and past year's, which we have already learnt. So now the weight applied is Q0 plus Q1 divided by 2. And here also in the denominator, Q1 plus Q1 divided by 2 is the weight applied. And then it is multiplied by 0. So this 2 and 2 will be getting cancelled. And after that, this multiplication, sum of P1 Q0, that's what is written here. Look at the cursor properly. Sum of P1 Q0, that's what is written here. Plus in between, sum of P1 and Q1 divided by sum of P0 Q0 plus in between sum of P0 Q1 multiplied by 100 as it is. So here, as I have said, this 2 and this 2 was getting cancelled. So here also I suggest you students, don't remember the formula of Marshall-Edgeworth to be like, the cursor you can see. Don't remember like, sum of P1 Q0 plus sum of P1 Q1 divided by sum of P0 Q0 plus sum of P0 Q1 multiplied by 100. In this way, if you remember, you may get confused sometimes what to be written, whether P1 it is or Q0 it is, P0, Q1, all those you may get confused. But you should remember the concept very well. Sum of P1 and P0 as usual. I mean to tell sum of P1 divided by sum of P0 for price index number, that to weighted price index number, it is a common factor. And then Marshall-Edgeworth price index number is nothing but Q0 plus Q1 divided by 2 is the weight applied both to denominator and the numerator. Then 2 is getting cancelled, multiplying all these. This concept, when you remember, whenever it is asked to write this formula or the problems based on all these formula, when you are calculating, you will not go wrong in writing formula. And for your information, these are very, very important formula which we are learning now. Fixed question in section D as question number 38. We will have 10-mark question based on index number. Therein, all these index numbers only will be asked to calculate. So these are very, very important, formula. The concept is very, very important in terms of examination viewpoint. Hope you are getting my point, students. How to write all these formulas, which we have learnt first 3. Then next index number, which it is, try to recall. It is Dorbish-Bowley's price index number. What is Dorbish-Bowley's price index number says? This is arithmetic mean of first 2 index numbers. Which are the first 2 index numbers? Last year's and past year's. So Dorbish-Bowley's price index number is arithmetic mean of last year's and past year's index number. Sometimes the question may be of this kind: what is the relation between Dorbish-Bowley's price index number, Laspeyres price index number, and Paste's price index number? At that time you should write Dorbish-Bowley's price index number is arithmetic mean of Laspeyres and Paste's price index numbers. So that's what has been given here. Dorbish-Bowley's index number is arithmetic mean of Laspeyres and Paste's index numbers. So how to write that using notations? This is what is P01 dB. dB is nothing but Dorbish-Bowley's. This is arithmetic mean of Laspeyres and Paste's, it seems. We know already Laspeyres index number, it is being written P01L plus Paste's price index number is being written as P01P. P01P nothing but Paste's price index number. This Laspeyres price index number plus Paste's price index number divided by 2 will be arithmetic mean of these two. That's what divided by 2 has been taken as 1 divided by 2 outside and has been written in bracket P01L plus P01P, which implies this half as it is. Then P01 Laspeyres price index number of Laspeyres, we know already, sum of P1 by sum of P0 and Q0 as the weight supplied plus sum of P1 divided by sum of P0 Q1 as the weight supplied as Laspeyres and Paste's respectively multiplied by 100 as it is, like, you know, in terms of index numbers. Here you have to keenly observe, students. This side, right hand side, what we have written, the simplification of the first, we are writing multiplied by 100. But here multiplied by 100 is not there. Look at the cursor properly. Here we are writing multiplied by 100. But here we have not written that multiplied by 100. Once when you are substituting Laspeyres index number, it's already multiplied by 100. What was Laspeyres index numbers formula? That is nothing but sum of P1 by P0 and then Q0 as the weight applied and multiplied by 100 also was there. So here once when we are writing as price index number based on Laspeyres, it's already multiplied by 100. And here also once we are writing as the index number of Paste's, it is already multiplied by 100. But here only the ratio we have written in place of Laspeyres and in place of Paste we have written only the ratios, and multiplied by 100 and multiplied by 100, here both the sides it is present already, and you can assume it to be, it is taken common 100 out and then it has been written without 100 here. That way also you can understand, not an issue. But here as an index number when it is considered, it's already multiplied by 100. Only here the ratios are considered. That's why once again we are keeping this 100 multiplied as it is at the end as usual for a index number. Hope you are following me, students. So here both base year as well as current year quantities are used as weights, wherein for Laspeyres it was used only base year quantities, for Paste's it is used only current year quantities. But here in terms of Dorbish-Bowley's, it has been used both current year as well as base year quantities. Obviously in previous index number Marshall Edgeworth also both base year and current year quantities were used. Then next, what is the index number? I mean, which index number comes next? It is Fisher's index number. The relation between Fisher's index number, last year's index number and past year's index number also I have said you already. What is that? Fisher's index number is the geometric mean of last year's and past year's index number. The previous Dorbish-Bowley's was arithmetic mean. Based on arithmetic mean it was. Here Fisher's price index number is based on geometric mean. So that's what Fisher's index number is, a geometric mean of the last year's and past year's index numbers. How to write using notation? P01F indicates it is price index number based on Fisher's. Geometric mean of last year's and past year's, it seems. We know already whenever two variables are there, or for example A and B are the values, how to calculate the geometric mean of those A and B values? It is the square root of AB. That means we know already geometric mean is nth root of square root of multiplications of the observations. So here only two observations are present. Observations are nothing but as last year's index number and past year's index number. That's why it is square root. Nothing has been written here, means it is 2. That means it is square root. That is the reason here as a geometric mean we are writing as the square root of P01L multiplied by P01P. Once again these can be expanded in terms of P01L. We can write its expression. Here you can look at the cursor. Multiplied by P01P, once again its expression can be written. Only this much is under square root, and multiplied by 100 is as usual for any index number. Next, which is the index number to come? Okay, before that, anyhow, here also we have used both base year as well as current year quantities. So it is the third index number which we are coming across, which has been used like both base year as well as current year quantities. In case of Dorbish-Bowley also, and in case of Marshall-Edgeworth also, and here in case of Fisher's index number also, we have used both base year and current year quantities. Okay, which is the next index number to come? Kelly's index number, or Kelly's price index number, or it will be called as fixed weight index. Since it is fixed weight index, we will be not using here either Q0 or Q1. Only simply Q will be used as the fixed weight. So here Q denotes the fixed quantity or a fixed weight for both base and current period. So the expression goes in this way. P01 is as usual notation. K is nothing but Kelly's price index number, and sum of P1 divided by sum of P0 as usual. Q and Q is the weight applied, and multiplied by 100 as usual for any index number to express in terms of percentage. So here till this we have come across 6 weighted aggregative price index numbers. Try to recall once again which are those. Serially you must be in a position to tell. I have already told you. First one is, you can try to recall and tell. First one is last year's, and then next one is past year's. The third one is Marshall-Edgeworth. The fourth one is Dorbish-Bowley. The fifth one is Fisher's index number. And then the last one as the sixth is Kelly's price index number. And try to tell which are the weights applied for those price index numbers also. First one, it was last year's index number. There it was applied Q0 as the weight. Why Q is being applied as the weights here? I mean quantities, base year quantities, current year quantities, why we are applying as the weights? Since these are price index numbers, weights applicable will be quantities. Once when we are calculating quantity index numbers, at that time we will apply price as the weights. So try to recall, for last year's price index number, what is the weight applied? It is base year quantities, which is nothing but Q naught. And second index number was purchase price index number. The weight applied was Q1. It is current year quantity. Q0 was for last year. Q1 is for purchase. And after that, which one was to be considered as the third index number? It was Marshall Edgeworth. There, the weight applied was the arithmetic mean of Q0 and Q1. That means Q0 plus Q1 divided by 2. And then, which was the index number? It was Dorbish-Bowley's. Dorbish-Bowley's index number is the arithmetic mean of first two index number. That means arithmetic mean of last year's and purchase index number. And then the Fisher's is the geometric mean of last year's and purchase. And then the last one is Kelly's, which you are observing now on the slide, which is to be called as fixed weight method. Here we are not using either Q1 or Q0, just we are observing here as Q as the weights to be applied. So next, second major classification in weighted index number we are coming across now. For your information, index numbers were classified as unweighted and weighted. In that, weighted as well as unweighted are further classified as simple aggregative and then average of relatives. So in that, particularly in weighted index number, we had completed just now weighted aggregative price index numbers. That means aggregative is over. Now weighted average of relatives we are considering. It is weighted average of price relatives index number. Look at the cursor. Since it is weighted, W will be present. And then average, it is this average, either arithmetic mean or geometric mean we will be specifying. Of price relatives, what is price relative? P1 by P0 multiplied by 100 is price relative. You know already all these. So how weighted average of price relatives index numbers will be, we shall concentrate. The average may be arithmetic mean or geometric mean. Here the average which we have specified, that may be either arithmetic mean or a geometric mean. The same way we had come across even in unweighted index numbers also. Unweighted or simple index numbers. Simple average of relatives also we had studied in the previous video. So here, if you have an arithmetic mean as the average, what it will be, we shall see in the next slide. Okay, here appropriate weights are assigned as the various items. Here appropriate weights are assigned to various items and the weighted average of the price relatives is calculated. Here we are not applying either Q1 or Q0 blindly as the weights. An appropriate weight, practically what it is, like, to be applied as the weight, that weight is being applied. That's why in terms of weighted average of price relatives, weights we will come across as W. Whatever the appropriate weight is being applied will be denoted as W. The weighted arithmetic mean index number is, based on arithmetic mean we are observing now, it is summation of WP divided by summation of W. It is nothing but, or it is very much similar to weighted arithmetic mean. Sum of Wx divided by sum of W we were considering in terms of weighted arithmetic mean. In the last year syllabus we have learnt it. In place of X we are having here P, because it is the method based on price relatives. This is the capital P, try to understand. It's not a small p. What is capital P meaning? It is price relatives. What is price relative? P1 by P0 multiplied by 100, and W is the weight applied. The weighted geometric mean index number is, in terms of geometric mean, when you see what it will happen, in the last video also we had come across geometric mean index number, but there it was simple one, that's why W was not there. That means it was unweighted, not weighted one. What was earlier in terms of unweighted? Antilog of sum of log P divided by N, it was number of observations, correct? Since here W is the weight applied, we are getting P01 to be antilog of sum of W log P divided by sum of W. Based on the arithmetic mean and geometric mean basic information from your previous year's syllabus, you can very well make out all these differences in terms of index number. Only one caution, students. Majorly I have come across students making one mistake in terms of the weighted geometric mean especially. Instead of writing sum of W log P, some students will write it to be sum of log WP. It's not log WP. Take it very seriously. Sum of W log P it is. Don't interpret later it to be log WP. W is multiplied to log P. That way the concept is. Okay. Where P is price relative and W is the weight of the commodity. In both these cases, P is a price relative, which is P1 by P0 multiplied by 100, as I've already told you. And W is the weight of commodity. Whatever the appropriate weight is applied, that indicates W. So in the next class, we shall come across the problem solving based on all these weighted index numbers. Weighted aggregative, weighted average of relatives, all these we may have to come across problem solving in the next class. Thank you so much. Take care. Keep practicing.